So hello everybody, welcome to my YouTube channel Java Guru Ravi, and I Ravi Kansa welcome you in this new video. So let's get started. So hello everybody, today in this video we are going to start with the collection framework. So in this video we will be discussing the hierarchy of the collection framework. So collection framework, first of all we need to understand what is the collection framework. So it is similar to the STL in C++, but here we have enriched set of classes, full-fledged libraries available where almost every type of data structure is provided in the form of inbuilt classes. So let us understand the collection framework. So first of all, the collection framework classes are available in a package java.util, right? So if you have to use any of these classes, so you need to import this java.util package. Second thing I have already discussed in the generics, these set of classes are generic classes, means whenever you have to create any collection, so you have to define what type of objects you want to store. So collections in Java stores objects only, and you have to create a generic collection so that it can ensure that only that type of objects are stored in the collection. So in this entire collection framework there are two families. One is collection family, other is the map family. So there are two different families are there, and they don't have any relationship. They are not having any kind of relationship with them. The only thing that is common is they both belong to the collection framework, right? So what is the difference between the collection? There are multiple interview questions from this collection framework. Like what is the difference between collection and map? What is the difference between iterator and the list iterator? What is the difference between list and the set? What is the difference between comparator and comparable? These are all interview questions frequently asked in the different companies' placement drives. So let us understand all those stuff today here. So collection family, the behavior of the collection family is it stores objects only. It stores objects, right? It will be storing the objects only. But the map family is having some behavioral difference. It is saying that we will be storing the objects, but there should be some key to identify those objects, right? So basically map is saying we will be storing key value pair. Key value pair will be stored by the map, right? And map is useful when you want to perform searching, and for searching the key is there through which you will be performing the search operation, right? So whenever you want to ensure that you are going to perform faster search, you can go with the maps, and to ensure the faster search you will be having the key over there to identify the value, right? So this is the basic difference between the collection and the map. That's why they are not having any relationship. Now coming to the collection. So collection is an interface. That's why all those classes are there in the rectangular boxes, and rest others are interfaces. In between there are abstract classes. I have not listed them, right? So collection is an interface. It is having three sub interfaces. You can say collection is a grandparent. It is having three children. One is list, second one is set, and third one is queue. So again these three sub interfaces are having their own property, right? They are having their own property, and that is very important to understand. So what are the properties? Mainly we talk about the list and the set. So what is the feature? What is the property of the list? List provides you the feature of indexing. List support the indexing, right? In the list subclasses we have the indexes available, which is not available with the set, right? Indexes means you can add the element in a particular index, you can delete the element from index, you can access the element from any index, you can update the value on a particular index. All these facilities are available in the list, but in the set we don't have the indexing. You cannot find the third element of the set directly. right? So set does not support the indexing, right? Same as with the ordering. Ordering is also not supported by the set, but list is supporting the indexing and ordering. Now coming to the set, what is the property of set? Set is also having some attribute which is to be understood. Its property, what is the property of the set? The set is providing the property of non-duplicacy, right? Any set subclass will not allow to add some duplicate element. It will automatically discard the duplicate elements. It is very useful to find the solutions of many problems where duplicates are removed. So non-duplicacy is the beauty of this set. Automatically, you need not to write any logic. If you are given ki, okay, this is an array, and for find all the non-duplicate, delete all the duplicate element, simply add the array elements in the set and get the elements, you will get all the non-duplicate elements. So this is what the beauty of this set. Q is performing the same Q kind of behavior as you have studied in data structure, first in, first out. So Q key, there is one subclass linked list. There are some other classes, array DQ is there, priority queue is there. So all those are there. Linked list is the only class. Here you can understand linked list is a special class because it is inheriting queue as well as list. This is the only class which belongs to the two families. It belongs to queue family as well as list family. So it inherits list as well as queue. So this is what the linked list is. So I have explained the difference between the list. List is indexing and ordering. Set is non-duplicacy. Queue is first in, first out. Right? Similarly, now list subclasses are there. Two subclasses, array list and vector. So what is the difference between array list and vector? Array list is a normal dynamic resizable array. Right? You can say it is a general purpose array that we normally use. But what is the difference between the vector and the list? Array list is, I told you, synchronized. Vector is synchronized. So synchronized array list you can say is vector. Vector provides you the feature of synchronization. Synchronization means multiple threads cannot access it simultaneously, similar to the string buffer. A string buffer is synchronized and string builder is unsynchronized. Similarly, vector is synchronized and array list is non-synchronized. If you feel that you have created some collection or data structure which should be accessed by only one thread at a time, you will go with vector. But if you feel that my data structure should be accessed concurrently by multiple threads, then you will go with the array list. Right? Synchronization is not implemented in array list, whereas synchronization is implemented in vector. And there is a subclass of vector which is stack. Stack, you already know, it provides you the last in, first out behavior. Right? The stack provides you the methods push, pop, peek. All those methods are available in the stack. It is a widely used data structure and every stack is synchronized. That's why it is a subclass of vector. Why stack is inheriting vector? Why not array list? Because stack is always synchronized. Right? Once you are performing the push operation, at the same time pop operation should not be allowed. Okay? So stack is synchronized. Similarly, set subclasses are there. So in case of set, I told you all set subclasses will ensure the non-duplicacy. But again, three classes are provided: preset, hash set and linked hash set. So there is a hash set class, a normal set, you can say, a normal set behavior where duplicates will not be allowed. But ordering is not maintained. It might be possible you have added 4 elements, but the first element will be present at the third index. Indexes are not there, but in the third place. So if you are adding the elements, you are not guaranteed to get the element in the same order, because it is not providing you the ordering. If you want ordering, you have to go with the list subclasses. Right? So here duplicacy will be removed, but all elements can be retrieved in the different order. If you want to retrieve them in the same order, then we have the linked hash set. Linked hash set will ensure the non-duplicacy, but it will also provide you the elements in the same order in which you are adding. The difference between hash set and linked hash set should be clear. Both are removing the duplicates, but if you want that element should be given me back in the same order in which I have added, you will use linked hash set. But if you feel the ordering doesn't matter, only duplicates should be removed, you can go with hash set. Right? Then we have tree set. Tree set is used for sorted order. Tree set says elements will be added, duplicates will be removed, and result will be given in the sorted order. Right? So totally it's your choice. Do you want to get the elements in the same order? Use linked list. If you don't want the ordering is not a important aspect for you, you can go with the normal hash set. If you want in the sorted order, you can go with the tree set. So all choices are there in your hands. Right? Same with the map. In case of map, as I told you, key value pairs are stored. So you have hash map, you will be adding the key value pair, and key value pair is called as entry here. Entry. Right? So map is an interface, and inside the map interface there is one more nested interface, that is entry. Right? You have an interface map, something like this, K and V, key and value type, and inside this we have another interface, that is entry. Entry is again taking key and value. So this is, you have already got the concept of nested classes. So this is a static nested class. Interface cannot have a non-static nested class, right? So this is static nesting. So entry is an interface. So this is map.entry. Map.entry, static nested class, map.entry, right? So a key value pair, let's say I have written 16920 Ravikant Sahu is a key value pair, and it will form an entry, right? So in the maps, entries are stored hash map. You will add the entries, but it is not guaranteed that you will retrieve in the same order. Linked hash map will give you the entries in the same order in which you have added. Tree map will give you the entries in the sorted order based on the key. All those operations will be performed based on the key, not based on the value. So this is your map family, right? So I think I have explained the difference among all these classes. So you should be very clear about the difference between map and collection, list and vector, then set and list. These are very popular interview questions. So that's all for today. Thank you so much.
So I hope you enjoyed this video, and if you find this video useful, so please like, subscribe and share with all of your friends so that they can also get benefited. Ravikant Sahu signing off. Thank you.